Hey everyone, we're back and today we're doing Unit 4, Lesson 5, Math Modeling Day 2. Just want to remind you from yesterday, when you're doing these types of problems, we want to draw a picture, we want to write the basic function, then we want to put in the information from the picture to the function, substitute any values we can, and then lastly, we want to rewrite it in terms of a specific variable, whatever is given to us in the problem. So our first problem today, the perimeter P of a rectangle is 50 feet. Express its area as a function of the length X of a side. So when we're looking at this, the perimeter of the rectangle is 50 feet. We want to express the area as a function of the length X of a side. Since I wasn't given a picture, I'm going to make a rectangle. And I have X and Y. And so everything's, we're going to be in terms of X here. Express the area. So this is our basic function. The perimeter, we're going to go back to in a minute. Express the area. Area equals length times width. That's what we want to write the function. And we want to write it in terms of X. So piece by piece, we're going to get rid of the L. Then we're going to get rid of the W. Then we're going to write it with all X's. So now we go back. Area equals X times Y. That's the information from my picture. Okay, now here's the tricky part. They give us in the problem that the perimeter is 50. So in terms of this problem, our perimeter is 1x, 2x, 1y, 2y. And we know that has to equal 50. And here's our key piece of information that helps us relate our x's and y's. So if we solve this, 2y is going to equal 50 minus 2x, divide by 2, y equals 25 minus x. Now that I know what y is equal to, right, now I can just replace it. And I can write y in terms of x's. And again, just like we did yesterday, we want to represent that we're dealing with a function. We're getting area by plugging in all x's. And we're going to do our best to write this in standard form. And there is a reason for it. I know I say it. We'll see it tomorrow. And that's it. Okay, so the area of the rectangle as a function of x. In this next problem, we have a wire 50 feet long is cut into two pieces. One piece is a square and the other piece is a circle. Express the total area enclosed as a function of the length x of a side of the square. This one's a little tricky. Okay, again, did not give you a picture. If I put something like this on a test, though, I would definitely put a picture for you. So we have a wire that's 50 feet long. That's just my little way to represent my wire. And it's cut into two pieces. One piece is a square and the other piece is a circle. So basically, I have a square and I have a circle. Okay, so that's what's going on. Express the total area as a function of length x of the side of the square. Okay, so that's a huge, important piece of information. I'm going to actually just right now, area, the total area is going to be the area of the square plus the area of the circle. Yes, I start that basic. Total area is going to be, well, what is the area of this square? Length times width, or side squared, whatever you want to do, it's going to be x squared. And the area of my circle, if you remember correctly, is pi r squared, right? That's my circle. While we're at it, what's the circumference of a circle? Circumference of a circle, hopefully you remember, is 2 pi r. These are two formulas you've got to know, your area and your circle. I mean, your area and your circumference. I'm going to write this nicer for you guys. There's our circle formulas. Okay. So now our problem is we have an r and we have to get all x's. So we have to go back to the picture. Let's remember, this whole entire piece here, this whole entire length of wire is 50. So if we cut off the top portion and we form a square out of it, how long is this piece? Well, the perimeter of the square is 4x. And now if we have that big piece of wire, 50, whatever it is, 50 feet long, and we cut out 4x, okay, well, the piece that's left is going to be 50 minus 4x. Now, the important thing here is for you to connect that this 50 minus 4x is wrapping around and forming this circle. So that tells us that our circumference of our circle is 50 minus 4x. And what do we know? We know that the circumference formula for a circle is 2 pi r. So that must mean that 2 pi r equals 50 minus 4x. So now once we have this connection between the r and the x, we can solve for r and substitute that into our equation. So I'm going to take, and I'm going to do 50 minus 4x divided by 2 pi. And that's gonna, I can reduce it a little bit more because I have this, right? 25 minus 2x all over pi. Now we're going to take this, what r is equal to, and substitute it right in there. So my total area is going to equal x squared plus pi times 25 minus 2x over pi squared. Unfortunately, we have to do a lot of cleaning up for this one. It's a little bit of algebra nonsense. So my total area is x squared plus pi. Now in the numerator, we have to 25 minus 2x. Oh. I just need a place where I can kind of fit this. 25 minus 2x times 25 minus 2x. So we have 625 minus 50x. Minus 50x gives me minus 100x plus 4x squared. And that's going to be over pi squared. And we're going to see that the pi is going to cancel. And the total area as a function of x is going to become x squared plus 625 minus 100x plus 4x squared all over pi. And I'm going to actually say that it's okay to leave it like that. Some of you may want to go ahead and make it a single fraction, but I'm okay with that answer. Let's move on to the next example. Now we're going to get a little bit trickier. These are going to be a little bit more involved. A closed box with a square base is required to have a volume of 10 cubic feet. Express the amount A of the material used to make such a box as a function of the length X of a side of the square base. This one is rather tricky. Okay, first of all, we're going to have a closed box. Oh, I wish I drew a better box. So that's sort of what my box looks like. And it's going to have a square base. This is important. If it has a square base, that means each of the side lengths of the base are both X. Express the amount of material to make the box. Okay. So now you have to think about it like this. If you're expressing the amount of material, you want the outside. You want the area here, the area of the back, the area of the four sides, the area of the top because it's closed, and the area of the bottom. If it was an open box, you wouldn't have to have that area. Okay. So when we're dealing with this problem, we're dealing with surface area. Now I have my square base, but now I need to figure out a variable to use for my height, which I'm actually just going to use y. Okay. Usually when I use x's, I use y's as well. So my surface area, and in this particular problem, it's the first time that I kind of say to you, ignore your geometry surface area. Okay, ignore that complicated formula and go based on your picture and take it right from your picture. So for example, I know I'm going to need the area of the bottom and the top. They're both the same areas, and they're both x squared, so we have 2x squareds. And now if you look, I have to do my sides, right? All four sides are going to be the same. They're going to be length or base times height. Base times height. Base times height. Base times height. So we're going to have 4 of them, and each of the areas is x times y. Now our goal here is to get rid of that one y and write it in terms of x's. Go back to the other piece of information in your problem. We're going to have a volume of 10 cubic feet. Volume is length times width times height, which is 10. X times y is 10. X squared y is 10. Remember what we're trying to do. We want to solve this guy for y. So now we can take what y is equal to and substitute it and get our equation in terms of x's. So our surface area formula, 2x squared plus 4x times 10 over x squared. Clean this up a bit. 2x squared plus, I have 4 times 10 is 40. 1x cancels with 1 down there, and I have 40 over x. Sometimes in this class, I might ask you to express this as a single quotient. So in which case we've kind of practiced with fractions. Think about this. If I have 2x squared plus 40 over x, and I want to write that as one fraction, I need to multiply this guy by x over x. And then I can combine like terms, right? So I'm going to kind of cheat a little bit here. Now I'm just going to do, this is my surface area formula in terms of x. Again, it's just notation. And that's going to equal 2x cubed plus 40 all over x. I do want to point out to you guys, I'm pretty much okay with that unless the problem tells you to express it as a single quotient. Then I would prefer that you go the step further. Okay, and there is reasons. Okay, because sometimes we need to write an equation in a certain form in calculus to do something with it. Okay, so we need to know both forms. Our last example today, water is being poured into a cone with a radius of 4 feet and a height of 16 feet. Express the volume V of the water as a function of H. Express the volume V of the water as a function of R. Okay, so this is a really kind of fun little problem. Okay, we see this a lot in one of our chapters in our calc class. So we have a volume, we have a cone. Our cone has a radius of 4 feet. And the cone has a height of 16 feet. And you're just dumping water in there. So we want to do two different things here. We want to express the volume V of the water as a function of H. I'm sorry, yes, of H. So our volume formula, I should write that here. The volume formula for a cone is 1/3 pi r squared H. So we want to take this volume formula and here we want all H's. And here we want all R's. Okay, that's basically what's going on. Okay. And it's going to be pretty easy. So the first thing we have to do is recognize or see, okay, I need to get all H's, so I need to replace R. But they didn't give me any other information. A lot of times they in the other problems, they gave us a side thing that told us what the perimeter was, or that told us what in the top one, it was the volume. So here we don't have anything. What we have to know is, if you look at this, we've got a right triangle here, correct? So as my water level goes up at each point, I make a right triangle. What do you know about right triangles? Hopefully you remember that in a right triangle, side lengths are in proportion. So that's what we're going to use when we deal with this problem. R is to H as 4 is to 16. So if you think about the first problem, we need 16R equals 4H. Okay. So we need to get this. We need to solve this for R. R equals H over 4. Because now, every place I see an R, I can replace it with H over 4. And then we're going to clean up this formula. H squared over 16 times H. So the volume formula as a function of H. Now if I just multiply across the top here, 1 times pi times H squared times H, I'm going to have pi H cubed. And then in the denominator, 3 times 16 over 48. In the next example, we want to go back here to our proportion. And I take 16R equal to 4H. except this time I want to replace the H with an R, right? So down here, I need to solve for H, right? So I get H by itself. H is going to equal 4R. Now in this example, I'm going to take the H out and put the R's in. When I go to clean this up, well, this one's a little bit easier. 4 times pi times r cubed. 4 pi r cubed over 3. And I'm actually going to represent that I know that this is a function of r. And there you have it. Okay, so we did a whole bunch of different types of examples. Hopefully you'll practice, and we will use some of them a little bit in tomorrow's lesson. Okay, see you later. Bye.